Let's go ahead and peek in on that large active region on the south. The best way to predict flaring when sunspot maximum is at peak is to analyze the sunspot magnetism. You find first the shape and geometry and spread, and then in the magnetic return you look for the close interacting opposite polarity umbra, the black spots. Do not be fooled by the peripheral opposite polarity surrounding the spots. This one actually could give us more flaring if it develops in that central region where blue and red are interacting. And we're off to earthquakes, where the top of the day was 6.0 at the tip of Antarctica, but only because the 6.4 in Tonga earlier this morning was downgraded to a 5.9. It's going to be a data and info onslaught at the end of the show, so let's get some nice eye candy before that. This is the animation sequence that goes with the latest simulation on merging black holes and their gravitational waves. Of course, they have no idea about the physics of these objects near and past the event horizon, but I can't sit here and tell you this isn't pretty. Let's continue with the pretty with a new sea level rise animation on the sphere, but just a reminder, the sea doesn't rise in some areas and fall in others. These are the results of current changes and the winners and losers of post-glacial rebound. Also, folks, at the ocean currents link in the list today, we've got these for every part of the ocean. I'm just showing one of them here, but each is pretty mesmerizing, including the one for the Gulf Stream. Likely going to see that one in a future morning show. Okay, brains on. U.S. climate report for October is out, and if you're wondering why you hadn't seen it shared across the net, it's because it can't help the global warming story at all. Boom, roasted. Super cool up next, literally and figuratively. Another class of microbe has survived outside the ISS in low Earth orbit. The freeze, the low pressure, the space radiation, and ionospheric plasma. Full story at the link below. Imagine a rocky planet so hot that its rock doesn't just liquefy into magma, but it vaporizes into gas. Up in the sky it cools, condenses, and drops as rocky rain. Fun planet. And now we're getting into the appetizer of the meal, cosmology. An excellent piece here on why dark matter is not the answer, and neither is a modification to Newtonian dynamics or gravity. The hypothesis still twists the fabric of space-time, somehow, but the key is to demonstrate that you don't need either of the former pair to explain the cosmos, especially since they are terrible at seeing it and yet have something of a God complex. They find first statistical detections of the cosmic web here, and since they declared most of the universe to be dark matter, they have done nothing but discover more and more normal matter where the dark matter was supposed to be. New work on recurrent nova events shows there are major gaps missing in the models. We have previously shown how no binary is needed and a mere change in space environment can trigger a micronova, and here they find that the orbital demands on a binary aren't working so well either. Every time they move the bucket to catch a drop, another drop falls where they previously had the container. Up next, the story is a mistake the authors only think they're making. They say the results are likely from a bias within the system they used, although they couldn't root it out, and something tells me that finding overdensities right near the sun, yellow, in the direction of the galactic center, X, is not really going to be an accident given that we're within the current sheet double layers now. It's what's causing all the changes on all the planets we've seen, but most importantly on the sun and the Earth. Earth's magnetic field is weakening, and we recently saw confirmation that the latest acceleration was in 2017. Today, we're seeing predictions of continued weakening of the field at a faster rate than we've already seen. Beyond this, the dynamo models of Earth produce ridiculous results, and they even acknowledge those failures, but alas, down, down we go. And last but not least, folks, during the major disaster, we know that we expect electrodynamic induction, discharge, and perhaps breakdown from the large-scale skeleton of Earth. This would be one of those sources of mantle heaving, the core mantle boundary lobes stretching up towards the surface. It's one of the sources of Earth fire, the stories from old, and crustal disruption. Now, we know which lobe is going to break first, the African lobe. The minor reason is geodesic. It is wide, perpendicular to Earth's spin, while the Pacific one is parallel. But more importantly, they detect that the African lobe stretches much, much higher from the core than does the Pacific lobe, and that it must be of slightly lower density, therefore more unstable. Folks, the other planet changes, the galactic sheet, the solar triggering to a Leviathan outburst, the myths and religion, the mantle heaving and crustal disruption, and of course, the magnetic field excursion about to bring about